In file management system, there are what we call file utilities. These are programs or routines which perform generic operations of data files. The first one is known as sorting utility. It will arrange records of a file in some defined sequence. So the keys will determine the sorting sequence of the file's record, and this utility enables users to specify their sequencing requirements for a file by means of input parameters. And this utility reads and sequences records of input file, and by means of various copying techniques ultimately produces an output file containing records of the input file in desired sequence. Another utility is known as searching utility. It will find a particular record in a file and then matches the specified key values with their values in each record to search the desired record. So efficiency of search algorithm depends on file organization. Take note of this. Searching a record from a direct or indexed sequential file requires much less time than searching a record from a sequential file. The next utility is known as merging utility. So we say merge combines records of two or more ordered or sorted files into a single ordered file. And this utility requires records of each of the input files to be sorted in the same order, although the record layout need not be identical. And then this utility places records from each of the input files in their correct relative order and producing an output file having all records in the same order as input files. Next, we have copying utility. It produces a copy of a file either from one unit of a storage device to another similar unit or from one storage medium to another. Another utility is known as printing utility. So it will print a file in a printer to produce hard copy of its contents. And this utility provides the facility to print file contents in different formats. And this utility also provides some selection and editing facilities to enable printing of parts of files. And it will provide special formats for printing files that contain program instructions rather than data. Then we have maintenance utility. This utility will copy data from one or more files to a new file selectively or updates a file's contents selectively. This is an example of sorting one key and two keys. In this area, this is an example of one key in ascending employee code sequence. So only this column, the employee code, will be arranged from highest to lowest because that is ascending code sequence. When you say two keys, what will happen if we have here employee code as the secondary key while the department code is the primary key? If we're going to arrange them in descending order, both will be arranged from lowest to highest. So this is an example of sorting by two keys. Here is an example of merging utility. For example, you have file A and you will have your file B. The contents will be arranged from highest to lowest, and that will become your output file, which we're going to call file C. Let's move on to the database management system. In database-oriented approach of organizing data, a set of programs is provided to facilitate users in organizing, creating, deleting, updating, and manipulating data in database. So all these programs, if we are going to put in place together, this will be a form of database management system. And in database management system, we have several models. When you say a database model, it will define the manner in which the various files of database are linked together. We have here the four commonly used database models. The first one is hierarchical, second one is network, third is relational, and lastly, object-oriented. So let's discuss them one by one. The first one is hierarchical databases. So when we say hierarchical database, links its data elements as an inverted tree structure, and below the single root data element are subordinate elements, each of which has its own subordinate elements, and so on also. So tree can grow to multiple levels. So there are many children elements and each parent element, but there can only be one parent element for any child element. Take note of that in hierarchical database. So main limitation of hierarchical database is that it does not support flexible data access. So applications can access its database elements only by following path formed by the branches of the tree structure. So here is an example of a hierarchical database. So this is an example of a child and this is the parent. Okay. Next, network databases. So we say network database is an extension of hierarchical database. So this type or model organizes its data elements in such a manner that they have parent-child relationship among them. And the designer must determine all types of relationships among data elements while designing the database. Then a child data element can have more than one parent. Take note. A child data element can have more than one parent element or no parent elements at all. So parents and child elements can have many-to-many relationships. So this is an example of a network database model. Third one, we have the relational databases. So this type of model organizes its data elements as multiple tables with rows and columns. And each table column represents a data field and each row represents a data record. Take note of this. This one is what we call tuple. So relationship database model provides greater flexibility of data organization and future enhancements in database such as compared to hierarchical and network database models. So here applications can organize their data elements in a relational database in a manner that it is identical to real-life relationships between data elements. So here in this particular model relational databases, users can also reorganize data elements when necessary to create new tables by selecting certain rows or specific columns from other tables or by joining columns and rows from two separate tables. So here's an example of relational database. Okay, so we have here this field, we have membership number, we have membership's name and membership address. So another for example, you want to create a database of borrowed books data table and they are linked together, and this another database, books in data table, but they are related among themselves. So here we have a sample report of overdue books from those tables. Lastly, we have object-oriented databases. Here in this model, some key features that several applications require for effective modeling are: we have first, ability to model complex nested entities, support for general data types found in object-oriented programming languages. Then this model supports for frequently useful object-oriented concepts such as objects, class, inheritance. Then we have support for proper match between object-oriented programming language and database languages. So please put in your summary note what is this object and programming language and define what is class and inheritance. In object-oriented database, it is a collection of objects whose behavior, state, and relationships are in accordance with the object-oriented concepts. In object-oriented databases also, they will allow definition and manipulation on an object-oriented database. So this model provides direct support for the definition and manipulation of the relationship among objects. So here is a diagram that will show you an object-oriented database. For those who will go to IT, one unit will be Introduction to Programming. So you will encounter this object-oriented database. It will be discussed furthermore in that particular unit. So main components of a DBMS, we have here four major components. First one is Data Definition Language, or DDL. It is used to define the structure or schema of a database. Another one is Data Manipulation Language, or DML. It will provide a command, or it will provide commands to enable the users to enter and manipulate the data. Third, we have Query Language. It enables users to define the requirements for extracting the desired information from the database in the form of queries. And we have Report Generator. It will enable the users of a database to design the layout of a report so that it can be presented in the desired format. So in creating a database, we have here three steps. First one, you need to define its structure, or what we call schema. Take note of the term schema. It is the structure of the database. And designing the forms for displaying and entering the data, and entering the data into the database. We have here a sample database form, and viewing, modifying, deleting, and adding records are other commands or actions of an already established database. So many database systems also provide a facility to set up a filter allowing user to browse through and view only those records that meet some criterion. So searching a database, you need to find command. It will be used for simple database queries, and as query language, it is used for more complex database queries. And query by example, or QBE, it will provide a simple user interface for specifying search criteria. So in creating reports from the database, so reports are generated by using Report Generator of a database system to assemble the output of the database query in the desired format. So this is an example of an output of a report. So that ends topic 7, and I have here some keywords and phrases which you're going to define and put it in your summary notes. After answering these keywords and phrases, answer my 1-minute write questions. The first question, what are the salient thoughts you have learned? How do you feel about them? And what are the things that are not clear to you? And send it to the email written in your unit information guide. That ends your topic 7 for this unit. Thank you very much. Have a nice day.